Ladies and gentlemen, welcome back. This is Soumya again, and I welcome you all to the third session of the AICT sponsored Adult FTP on AR and VR, that is innovation brought in by the digital realities and real time technologies. Our speaker for this session is Mr. B.C. Jainaresh, Education Account Manager, Unity Technology. Mr. Jainaresh is a leading education initiative for Unity in the Indian subcontinent. He started his career as an avid gamer who turned to become a game designer and started to work his ways in the game industry. In total, he has around 10 years of experience in designing games on mobile, PC, and console. He has journeyed from a game designer, producer, and consultant for various Indian, UK, and US based game studios. He has designed games for corporates, edutech companies, and entertainment units across various fields like serious game design, gamification of corporate systems, and content design for new interactive medias. Being an educator for 8 years, the technological geek has mentored and explored a variety of students and research projects in the new and disruptive technologies that expand students to think behind the horizon of the market and prepare entrepreneurs that actually highlight variety and impact. He also works across various education boards in the UK, US, and India. He shares his experience as Board of Studies member and curriculum course designer for various institutions. He is constantly exploring and fostering many people to adapt education through gaming or play approach. Currently, he is leading Unity India education initiatives and making Unity access to schools and colleges in India as a value-added addition for the Generation Z. So may I now invite Mr. Jainaresh to begin his presentation. Sir, over to you.
Thank you so much. Before I join with the presentation, I should thank because you took time to go out through the whole brief description about myself, right? So, but I want to rephrase it because normally I ask a question, how many people listen to it? But since this is in a out of that context, I just want to bring out a few important points, right? The first point is I became an educator by choice, right? And in fact, I was given a choice to do this or do the standard IT work that was coming by, and I chose to do something very different. And even in education, right, I choose to do something called as play by learning systems, which is a format in which you learn tangentially and not in a focused manner. Now, that is why today I'm also heading the Unity initiatives for education, and that is why I'm able to share the success stories of what has happened across the globe. The second important point that I want to bring in is today the world has changed. Now, though people might say it is because of the pandemic and other things that are actually in place, as humans, we have been impacted by the change and by the availability of technology to make this change possible. So in that direction, I always share my view that technology is just a tool, right? And how effective we make use of this tool leads to any kind of a change in the ecosystem is what I strongly believe on. One example that I give to everybody on that particular note is hammer. A tool as simple as hammer, if we are using it, right, we can only use it to break a few things or even, repair a few items. But in the hands of the same sculptor, the hammer becomes an art tool. Right? In the hands of a plumber, it becomes the most efficient tool to knock down walls and actually make plumbing possible. So whatever we learn today, I kindly request everybody to understand that AR, VR, or in another concept of digital realities, this particular concept, it is just a tool. And we need to explore how this particular tool can be used to make many other things possible. The last note is when we talk about AR, VR, right? It's only one element of what people call them as XR, extended realities, or it is nearly equated to digital realities. So I'm going to start my presentation now with this particular note. talking about how digital realities and real-time technology, how they are actually changing what is required in today's world so that people actually bring some kind of change in their existing ecosystems. So let me confirm that all of you are able to see my screen before I move on. Is it visible?
You have to share, sir. Screen. You have to share the screen, not visible.
I did do that. Just give me a minute. Okay, so this is Google Meet. Sorry, give me a minute. Is it visible now?
Yes, sir.
Right.
Yes, it's visible.
Slowly.
Yes, visible.
All right. So today we are going to focus on what are the changes that digital realities and real-time technologies have actually brought into space. Right? Let's understand first these two terms, digital reality and real-time technologies, so that we can move ahead. The first thing is digital reality as a textbook definition says any technology, it could be immersive technology, inclusive technology, experiential technology, right? Any technology which simulates variety of interactions for people to work with, right? So it's an umbrella term which includes augmented reality, virtual reality, mixed reality, which in turn contains vision, persistence, haptics, and interactions. Now, to make this easy for people, let's just understand going forward, right? If we are to give a technology name to all these systems like augmented reality and virtual reality, we will have digital reality as the umbrella term, which will consist of all these different items. And to successfully for somebody to work within this particular scope, there is a huge knowledge gap that people interpret with. So when I say something like as simple as real-time technology, people think that everything is real-time at the moment of hour, including Facebook, where you post something and immediately there is somebody liking it, right? In real time, you're able to see who is liking it. In real time, you're able to see how much of likes or dislikes you've got and the reactions that actually come with it. Now, real-time technologies are part of interactive media. Now, when we say interactive media, any media in which you are able to control the interactions or control data is what we coin as interactive media. So far, until 2014-15, all this interactive media was only kept in the form of what we call as video games, where people play with 3D artifacts or 2D artifacts or 2D graphics. Ultimately, you end up with a win and loss situation. Now, why video games? Because they were the first to apply it, extend it, and use it across multiple platforms. And video games have always been this complex software that needs to be written for entertainment. If you look at our textbook definition of a software, it is either application software or system software, right? And they have their own boundaries. When you say application software, it should make the user's task simpler. When we say system software, it is to do something with how the hard disk or any other system function within the hardware is maintained. And then you have this new breed of software, which is games, which do not fall under any of these two and fall under the entertainment category. But it uses the worst of worst algorithms. In fact, it is used to stress test your PCs in most of the cases. Why? Because the programming system which is followed inside is what we call as a real-time design pattern. Anything that you do, the system should respond back to you. And that is as equal as what the OS is doing. So in a format, it is an amalgamation of application and system to bring you a new breed of software, a new breed of programming protocols. And the difference was all of this was kept in your 2D screen. Your mobile phones, your PCs, your tablets, your gaming consoles, your TVs. But then things started to change. Instead of just having a 2D environment, people started going for a 3D environment. Now, the natural transition from a 3D has led us into these digital realities. So, what do you mean by these realities? Virtual reality, which is a natural extension of 3D rendering. So, 60% of any part of the sense, if you look at it, the human body can be cheated. And the best part is your eyes are responsible for controlling 58% of your entire sense. Your entire sensory system's biggest dominance comes from our eyes, right? Followed by the auditory system, which is nothing but your audio system, right? So if we can cheat your eyes and your ears to believe that you are sitting inside, let's say, a burning house, there is an 80% chance that you're going to believe that it is going to happen. That is where virtual reality had taken off. Virtual reality brought that impact to people, right? It gave people the needed things to work with and transfer you into a virtual world. Now, used right, this virtual world could be, let's say, the space and moon, where you can physically get transferred to moon. You can sit down in the moon and start studying its craters and other things if it is made in a simulation format. Now, if the simulation format is dropped for scientific basic exploration, it can be used for study of geography. And if you drop the seriousness level below, kids would enjoy going to the moon and seeing it, just like how they do in an industry trip. Now here, your vision's control is gone. You are blocked in a 3D view and your entire vision feels like you're part of a separate world. This adds to a lot of realism, and this helps you do multiple levels of immersion to the user, right? So the major difference here is you are given a VR headset, you put this on, you feel you are part of that particular reality. Now then came the opposite of this. What is the opposite of virtual reality? Augmented reality. Now what is the difference? Augmented reality looks at real world like Google Maps, and on top of the real world, it gives you some kind of augmented information. Like it tells you which direction to take. It tells you a left or a right. Now, a lot of people have extended augmented reality to identifying objects in 3D world, like your Pepsi cans, Coke cans, and they are able to create very immersive advertisements around it. And this is actually giving them a huge scope of saying how better we can use this technology. Right from buses all the way to fiber optic channel systems, people can identify where there is a pain point, which network has a threshold, how to improve it. Or it could be real estate people just going on a road and saying, okay, on the left there is a house vacant, you can try to purchase it. Now, this was only the beginning of things. Right? When I say beginning of things, it gave birth to a new reality aspect, and that was spearheaded by Microsoft themselves, which is called mixed reality. It takes the overlaying information and the 3D rendering system, mixes it together, and also understands the 3D space you're in. When I say 3D space you're in, let's say in front of you if there is a sofa and you're rendering a virtual fish, it knows that it has to render it beyond or before it. So I'm just going to give you a rendering example of all the three. So this is virtual reality, right? Where you're able to see the duck in a completely different environment. And then you have augmented reality, where the duck is an overlay which is translucent in nature, and you're able to see things that behind that particular duck. The same duck, when you actually render in mixed reality, right? Because it is content and space aware, it exactly tells you that there is a table in front, and this particular table needs to be occluded, that is a word we call, and then you actually render the duck. So this helps people do a lot more realistic projects, right? One more example of it, we are completely digital world. You are shut out from the real world completely. Then you have augmented reality, where you render something on top of it. And then you have mixed reality, where it understands the space, and based on the space, it's able to render out items for you. These three things are changing how today the world is working, right? In fact, in India alone, it has affected 6 different industries, which ranges from education, simulation, space and training, sports. It also extends its arms and legs in the media and entertainment field on films, even how films are being shot today with virtual background, everything has been changed. Now, all these three things put together is what we call as XR. Nobody used the word digital realities today. The X stands for, it could be augmented, virtual, or mixed. So when we say XR, this is the actual meaning and how this is transforming today's world is what we will look in further slides. Now, any questions at this point, please feel free to use the chat window so that I can actually bring some topics into the discussion. Now, why are we talking about this today? Obviously, the adoption of these technologies has grown by 100 times just because of COVID. In this pandemic age, we have seen more companies adopting it, more industries using it, and we are seeing more technologies being disrupted by this particular one. In fact, today it has become so common that everybody has heard of AR, VR, at least in the west side of the world. And on the east side, especially China and Japan, with Korea, they are no more newcomers. They are all experimenting these things for video consultations, for healthcare, and also for other benefits that actually brings the real estate into their hands. So this particular technology has started driving a lot of disruptions in the market. So right from the basics, where we are seeing the workforce is not ready for the digital age. Today, if I take an engineer, put him on, let's say, a bottling plant like Shemaru or shampoo, and suddenly the plant gets stuck, the engineer will not have a clue of how to troubleshoot it. In fact, the plant engineer, if he goes even on a day's break, the whole plant has to suffer some level of production. In fact, this is going to be one of the key challenges in automizing any technology. So what do? Today we are able to provide digital solutions where somebody can just wear a pair of glasses, which is either AR or mixed reality oriented, go to the work location, telecast the entire learning to somebody as a subject matter expert sitting behind a desk, and he's able to troubleshoot just by looking at what is available. This is highly sustainable, okay? And this is making more and more reliance on how people can actually support each other. So this is why I said these are the people who are thinking about technology as a tool, able to use these kind of technology tools for their betterment in lifestyle. So today, some of the most important technologies are being affected by this. So if people go around and ask a question, okay, what are some of the best disruptive technologies coming by? You're going to hear artificial intelligence. You're going to hear hyper automation. You're going to hear Internet of Things. You're going to have cloud computing in space. And if you look at most of the concepts of the new age, it could be Industry 4.0, it could be Education 4.0, or it could be something which is even related to, let's say, smart life, which is coming up. All of these technology concepts have augmented reality and virtual reality as a pillar that they need to build with. Today, most people rely on virtual reality to experiment, play, and create a sandbox of things to actually bring in. So a lot of people sitting at home are able to use virtual labs because this particular technology is in space. So new systems, what is happening in the world of Fortune 500 companies? They know they can't stop production. They know they can't cite reasons to give people. They know this is going to transform things. But at the same point of time, they all know and agree that they will have to change. So in this system, real-time technology is doing solid disruptions in the designing field. So what are these descriptions? First of all, let me click play and show you this. So a very simple example to show you the different industries who are actually using these technologies to move forward. In fact, today when we talk about digital twins, smart life, or education 4.0, you could see a lot of impact being made. So where do we start with? Oops. Just give me a minute. I think there's something wrong with my computer. All right, so this is much more visible. So what you're looking here is how people are using this technology to design big and major products, right? The automotive market has always been a leader in terms of innovation. because cars have been something that has been there from the industrial age. And they are somebody who has kept changing themselves and renovating themselves to give us what we know as cars today. Right from automatic all the way to self-driving cars is something that people are working today with. And this particular industry had a huge problem. The problem was physically they had to spend around 15 to 20 million dollars designing the first model, and then they will have to bring it to different people. And these clay models won't be accurate, and once you do your final casting, you would see there is a 1 or 2 millimeter differences, and the whole design has to be reworked. Today, in a scenario, right, you could do all that virtually. Let's say your mechanical department puts such a concept, it's called the virtual CAD room. Once you put up the virtual CAD room, people can work within this concept, all in imaginary metal, imaginary leather, imaginary steering wheel, all the way, having your final concept set up so that you exactly know what is your final bill of materials and how much of what do you need every time to use it. And the best part is if one person is sitting in Berlin, the other person can join in from India, Pune, and have the same VR experience as the other person does. And then finally, you will have Superman tools. So when I meant Superman tools, let's say you want to see a C-section of the car, which is immediately possible. You could slice and dice this whole car, find the C-section, figure out airflow, figure out dynamics, figure out and do some wind tunnel tests before you can actually make this progress forward. So in the design phase, it is not alone the automotive industry. We are working with aeronautical, we are working with aerospace, we are working with defense, we are working with tractor companies, we are working with smart farming solutions. So we are seeing astronomical difference of how people want to use and design this. The most recent trend which has started is defining digital twins in digital reality so that they don't have to do the real one. If somebody has worked with, let's say, IoT or any of those things, each and every one of those senses, what do they do? How do they do? How do you get somebody to practice using those senses? Because for a student who has spent 10 hours with sensors and another, let's say 200 with sensors, there is a huge skill difference. The confidence that he goes into a company to predict and say, instead of using a LiDAR 64 resolution, we should be using a LiDAR 128, makes a huge difference to the companies of today. So in design phase, we're able to add in a huge value to the whole cycle. And that is where we want to help people use, research, and work to see how much of other design patterns can be virtualized. This is pretty true in the terms of engineering it also. So once you engineer it, we are able to understand how it reacts because it's real time. Once your design of a bridge is done, you could do load test, you could do stress test, you could do any kind of hypothetical climate changes, and you're able to see what is going to happen at each point of time. So this is helping people not only engineer solutions, but also test their engineering ideas way before the actual practice build happens. And this helps by our partnership with Autodesk and other engineering partners who are giving us access to all these metadata of strength, which is possibly rendered in the front. This is where the new interest for people are at. They want to engineer solutions sitting at their home, testing it among a group of peers, and also using the same as proof points to convince the client of solutions. And when we are talking about autonomous cars and other parts of it, what we also understand is when you create a virtual system, it's easier to train completely on a virtual system. One great example is the delivery bots for Amazon, right? So one delivery bot in a warehouse, if you put it in a physical world, it is going to take 24 hours to learn 24 hours of its mistake. But then you have a digital world, and all you can do is you can have this into 10, into 20, based on the number of CUDA processors that you have in the machine. So now what happens is you can have multiple days in one day, and the virtual robot still has to use the same real-time operating system code inside a virtual world, learn by itself. So now what happens is you're training 10x faster, and your robots are much more trained for AI to pick up. And here you have the same thing: visual proximity, LiDAR-based systems, radar-based sensors, which help you do a lot of work for yourself. So that is what I mentioned by saying, if you are looking at machine learning, and if you're looking at AI as one of your core ethical drivers for your institution, you should be looking at how computer vision can be accelerated to get these kind of benefits as well. So it is not only engineering physical bodies or realities, it is also engineering solutions which helps you with better simulations and better trained subjects. Now, moving on to the construction space, right? We already know design is being hugely affected by these technologies. We also know the simulation part acts as a great proof point for the clients. But how about on the floor? Now, on the floor, you could visualize the entire new objects which were not beaten earlier. It can visualize, help the foreman with creating the objects, at the same time also give you review and analysis of how this can be done better. Suppose there is a loss of square feet in your construction, and if you want to change in real time, once you draw the plan or adjust the plan by, let's say, in one day, immediately when you actually put it up for preview, you can preview to the actual location and have a look at that. This changes everything what people have been doing so far. In fact, there are a lot of people who have extended this and even gone and monetized these solutions. But to just move forward from the construction space, so this is not only now an analytical tool, but it is also being used as a guidatory tool to guide people on the floor to design what they want. This helps you in two parts. Once you do everything virtually, the same content can actually get into your sales and marketing pitches. This helps people understand how the whole technology can be used either in VR, MR, or even any basic real-time solution to give customers a feel of it. So imagine that you want to buy a car which is another 2 years down in production. Just to have a feel of how things should be, you could walk into a showroom, and by using VR, you can have a complete driving experience. Or if it's a heavily customizable car, which is like the Aston Martin here, you could actually go to the showroom, choose your color, choose your leather, choose the dashboard, choose your engine power, and you can start applying all that, and then have one final checkout button to say what you want to do. This gives the final customer the satisfaction of things. At the same time, he knows what he is going to get, and there is a huge benefit against the prototypes of the physical nature to actually look at it. And the best part for the sales team is they don't have to stock up each and every car. Let's say Maruti Ignis, which has 5 different variants. You go to your reseller, they don't need to have Ignis at all. You could just put on your VR goggles, see how it looks, See, our fields have a ride with the driving simulator, and that driving simulator could replicate anything in future. Now, apart from getting the sales side of things, we also see this technology impacting the final customers, the end users, right? So we have seen smartphones become smarter. And when Android was coming up at the market, I remember a lot of people talking about how Angry Birds is playable on an Android phone, how you could actually use these kind of interactive tools to do a lot more effects. Now, the same thing is going to carry forward. The UI and the UX part is going to affect realities as well. When we talk about realities, one of the simplest thing on HMI, which is human machine interface, which we all understand is the dashboard on the car. Earlier, we used to be cassettes, radios, then now we are in touch screens. But what if we could do more? Right? If some of you have looked at Varjo's demo, it can now start predicting if you are going to hit somebody. So through computer vision, the car keeps a track of where you're driving, how fast you're driving, and then calculates it against other proximities, and it gives you help by saying slow down or speed up. It's all up to you. Ultimately, it's a proven concept today that people just use Tesla mode, which is, we say, car drive all by yourself. All you need to do is sit and watch, nothing else. So XR technologies are going to be not just affecting one or two processes. It is going to be affecting every process, both consumers and at the same time field operations. So one more example of that we are looking at here is this whole service manual being digitized, given to somebody as a series of steps in real time to follow, either for training, simulation, or on field operations. All that is now possible because the previous one, what we saw, was affecting end customers, and this one is affecting the same end customer in a working scenario. And this is all very true and happening in new virtual ergonomic systems where people are able to collaborate between manufacturing and user interaction design to give the best experience on the ground as well. The other form of service usage that we're going to see is going to be on the business end. Figuring out what works, figuring out management solutions, visualizing environments for which we normally expect CEOs and all the brainiacs to come down. Now they just need an interactive zone where they can all participate together and identify this. And real-time 3D will help you build that. This is where we are seeing a lot of impact from digital twins, where they are able to see one person working with the real project, and at the same time, in the digital twin, the other person is able to identify, analyze, and report back on the pipeline. So this is a great tool for people who have actually spent a lot of time collecting data from sensors and trying to explain those data to the managers. Now this is also going to shift how things are going to be. So what is a pipeline? What is that people can do, right? So there is a 3-step process. First, you will have to learn how to create all these virtual data. Right from interactions all the way to simulations, how do you build them? Once you learn that, how do you productivize it? How do you make it as a product which you can push across in terms of production and construction? So we will be able to see HMI solutions. We will be able to see digital factories coming up. So it could be students and the company, right? The company might allocate only 10 or 20 hours in a month to spend time with the student, but then you have a bunch of students who can put together this digital factory, completely all virtual, for, let's say, Siemens, who runs a huge Industry 4.0 panel, right? So this puts people for requirements, this puts people for the shift in technology, but at the same time still holding very true to whatever they are actually used to. Like a tractor manufacturing company will create a solution in AR VR for three different things. As part of the create, they will create virtual tractors. As part of the build, they will actually build digital twins or a sample product or a prototype which reacts and gives you multiple ways to analyze it. Now, in the space of monetize, it's easily the same images that can go to the sales and marketing team, but one step above us, as part of the service industry, it can also act as a great training tool. Why a training tool? Like, let's say your tractor is around $100,000. Once you start training on it, you'll always have the hesitancy to break it. Now, in a virtual world, you can stress it. If you break it, just like in a game, there is a reset button for everybody to work with and be happy with. So that is why in all these three different stages, we are seeing digital realities change what they are capable of. In fact, today, which is the last 2 years of the whole system, 2019 and 2020 have been very crucial, have been pushing completely most of these technologies into becoming reality, becoming practical usage. There have been people who have said real-time technology has already started, engaging it in a different spirit. But in India, we are seeing that most companies have started using it in one format or another, and they are now looking for these kind of transdisciplinary skilled spaces where people can collaborate. Now, there are different stages why companies are using it. First, for a production company, they see it highly valuable for design and prototype. Because your designers could be from anywhere. You could actually see the value once the design is ready into production. We are seeing that everywhere people have agreed that this particular technology has moved what they are doing, rather than just a few days waiting for things to come by, into quicker cycle of 2 hours or multiple hours to get that production done faster. So this is why we are seeing companies like Airbus, Boeing, Robert Bosch, Daimler, Ford working with us, working with a lot of new people and building a new set of tools from us. Building whatever is capable, whatever they see as the value this particular technology is adding into that particular scope. So for engineering, production, automotive, transportation, and manufacturing, we are seeing a huge shift in how these companies are moving it. We are seeing how the companies are more and more doing change in the systems to reduce cost, but at the same time have the flexibility of working on site. Now, before we get into the use cases, is there a few questions that you want to throw up so that I can answer it and then continue? Because after this, we're just going to look at a few use cases of how one company has used XR technology into getting into this particular space. The questions pop up somewhere, by the way?
So I have put in a question in the chat window. If you want, I can speak it out also.
Sure.
Yeah, so my question is, since we are mostly educators here, at least I am a passionate educator teaching grade 11 and 12 students, which is the best language, if any, to teach to the students for creating these experiences? Or is it more about domain knowledge for that particular area that is important for the companies? Thank you.
So I think the first and the foremost thing is going to be the foundation knowledge required to take it forward. If nobody understands the difference between AR, VR, MR, right? And even if they learn Python all the way from, let's say, textbook all the way to the end of whatever the high level is, they won't be creating solutions that match the requirement. Right? So that is going to be the one of the biggest change for us in the coming field. And apart from the foundation knowledge, there is not one single language that is preferred by all. If you look at it, there are 16 different AR, VR platforms. One of the most complex maturity stages that has come up only in 3 platforms, which is the Microsoft mixed reality platform. Then you have Google AR Kit, and then, Google's AR Core, and then you have Facebook Oculus, right? And these again use different languages. Today, you have multiple tools to architect a solution, right? You have multiple platforms that you can work with. So there is no one specific language or one specific way of studying AR VR.
Thank you so much for that answer.
All right. So the other thing I'm parallelly checking is, I know a lot of people said it's not audible. I'm still figuring out how to share things with audio. So if anybody has experience with Google Meet sharing audio, please let me know.
So if you're sharing one tab, it automatically shares the audio.
Okay.
But if you're sharing your entire desktop or the screen, then it will give you a problem.
Okay. So let me try to figure this out. If we close every other tab.
Actually, that not audible, we had put in that comment when you were sharing those that video.
Yeah, I didn't want to break the flow at that point.
Yeah.
Just hold on, one particular tab. I'm still not able to do that.
So when you click on present now at the bottom of the screen,
Okay.
you have the option of a Chrome tab. Click on a Chrome tab.
Okay.
Is the video in the Chrome tab?
Not yet. It's okay. Let me see if I can bring it to my Chrome tab.
Okay, even if it's not, just choose whatever you want to choose, your desktop or whatever, and there will be a checkbox. Once you select that, there will be a checkbox saying use computer audio.
Okay, if I click this, no, I'm not getting it for desktop. Okay, maybe for the entire screen. Nope, I still don't get it.
It's only for Chrome tab, I told you. Only when you use Chrome tab.
All right, got the idea. Let me see if I can move some videos to Chrome tab and see if it can work. Let me know if I'm trying Chrome tab at the moment. Let me know if you can see and hear things. Are we getting audio?
Yes, we are.
Right,
if you can just increase the sound a bit. Thank you.
Actually, the sound is full. It doesn't allow you to go full screen. Okay. So this is one of the customers, right? So if you look at it, to give you a background, Smart Pixel is one of our clients, right? And they are building Masteria, which is a huge tower, which talks about all the grandness So it has penthouse suites all the way to corporate offices in different floors. And they wanted to sell this. But during COVID, you could not bring people there, right? Literally, they are locked up. So what they did is they used AR, VR, and they launched this around 6 months back. And from launch, within 2 days and 1 month, the entire set of things were sold out. Not alone sold out, but also they were able to see what and how exactly each of their spaces would look like. Now, this is a complete VR experience. So you put on VR goggles, walk around, you select your floor, you're transported there, and it gives you a great example of putting up what you want to work with, and that help people in customizing things also. So I'm going to show you again. Stop. Okay, now this is a lot of things that I need to do here. How do I say? Okay, stop here. Perfect. And let me go into my demo videos to show you the customizations. Again, you're not going to see the audio part of it, but that's fine anyway. So what you're looking on the screen currently is a complete customization of the place, right?
Sir, I guess you forgot to share your screen.
Okay. Visible now?
Yes, sir.
All right. So when you look at here, this is the VR example. You are wearing your VR goggles, right? And you're able to look at your kitchen counterpart, and you're able to choose the material to use. Now, for a builder, this is a boon in disguise, because he exactly knows what to get you, right? And how many square feet of material, what material goes where, and there is a complete pre-rendered version of it, which means like he's literally giving you the power to do all this within a particular zone. And you can spend hours and hours on this, especially if you're buying a new home. Anybody who you give this app to, they're going to be spending around minimum 10-20 hours putting things up together, right? And once you do all that, you have a final version of how your house is going to look like. So this translates immediately into the bill of materials that needs to go into this location. That gives you an insight of the interiors that needs to be built up, and visually it is giving you a tool to reach your dream, right? So that's why I said this is very powerful to actually take it out. And I need to go to one more tab again. Just give me a minute. Or let's skip, let's do all the videos together at the last. I don't want to be doing this again and again, sorry. Let me get back to that screen. All right, I'm here. Now, before that, any questions? Let me look at the questions. Components inside AR VR goggles. The same goggle can be used for different application for manufacturing or construction. All right, perfect. So let me give you an insight little more to the technology part of it, right? So if you look at it, you will have a viewfinder. A viewfinder is the simple first glass that you look at. And behind the viewfinder is where you're going to have your focal lenses. These focal lenses are the ones that align. Now, everybody's face is different. So when I say everybody's face is different, mine is a little more broad and round face, where my daughter's is lean and oval in shape. So when I put on this particular set of glasses or a VR headsets, I need to pull in the focal lenses closer to my eyes so that I can see things better, right? And this particular shift is in millimeters. It's not a big one to crib or cry about, but that goes a long way into providing you huge benefits to the comfort zone. And then you have a render screen which renders out for you, right? Now, the higher the rendering resolution, the better it is used across. Today, at the aspect of time, you have very simply three things to worry about, right? The first one, headset, which is very famous, is called the Oculus Quest, which is a combination of a standalone headset, which means it's like your mobile phone loaded up with any VR game or VR solution, and then you're good. When I say you're good, you're able to view it without anything else interfering. The problem with this kind of a standalone devices is they do not have enough power to give you something as complex as an industrial solution, right? So that is where you see the other set of solutions like HTC Vive, HP Reverb G2 coming into play, where they provide you higher resolution. At the same time, they give you a bigger scope of what could be done. Again, it has its own disadvantage, which is you need a powerful PC to use it with. So when I say a powerful PC, it is just not a stronger i7 processor, but an equally stronger graphics card, right? So we call them as high performance visual computing devices, which can actually make rendering of CAD, rendering of animation films, rendering of games, or rendering of engineering solutions 10 times much faster. And is there any change between them? Yes and no. The base concept remains the same, but everybody has their own proprietary way of doing things. So if you look at the proprietary way of doing things, they are most suited towards a couple of things. The standalone devices like Oculus Quest, they are best for video games and roller coaster rides. They love to entertain people, so we are not so serious out with engineering applications. If you look at the Reverb G2 or the HTC Vive, they are far more complex and they are more preferred to do visualization, simulation, or any other industry benefit that you can throw out waste. And if you look at things beyond it, there are also things beyond it. At the moment of time, I'm going to say mixed reality devices. They do a lot more, right? If you pick up an object in real world, it also ensures that you pick up an object in virtual world, or vice versa. All that is possible, but those are specific use case driven installations, and which normally goes into a couple of crores, and they have exact physics. So something like creating a simulator for aircraft. So VR, AR goggle, they have the same concept, used differently based on notions. The special purpose installations are completely different, and they're used for what it is intended. The last thing that you need to understand is you can mix match these use cases to a limit. You could use the Quest and still show demos of real-time spaces and rendering architecture. Okay, you can still again play games on HTC Vive. So there is no difference. At the same time, you will have some level of difference to actually take it. Now, coming back to the presentation, how do you join the real-time revolution? All right, first of all, I normally say in terms of visual computing, you have, let's say, 5 to 6 years of graphics programming knowledge. Now, that has become an impossible task unless you are a dedicated educator who has spent time learning matrix multiplication, applying it to your rendering systems, and finally creating something with DirectX and OpenGL. Or you can just be another software developer and choose what we call as a middleware. A middleware is a solution just like your Visual Studio, an IDE of sorts, like MATLAB, like PowerPoint is a better example, right? So one of the tools that actually comes by is Unity, right? It is lightweight, which can scale down to the standalone devices as well. At the same time, it can do industrial work, so it can scale all the way to specially constructed installations also. Now, Unity is going to be a first step. When I say this with a lot of pride, but also with the right statistics involved. If you look at most of the companies in the past 3 to 4 years, whoever have started working on AR/VR, they've all started using Unity. Why? It doesn't have the complexity of the DirectX and OpenGL that you need to bring with. Unity has reduced the entry barrier for people to start learning AR/VR. The objective behind learning Unity is it's a stepping stone. And if you look at around 60 to 70% of the world, they use Unity and have deployed their applications. So today, we have 60% market share in all these different digital realities. Now, why do we want to do this? Very simple. All coding is not going to give you the experience of the 3D space as well. So you would need to handle 3D, you would need to handle coding, and you will need to handle design. When I say design, it's not the graphic design, but the design of the application itself. Any standard game, as an example, if you look at, you're going to have two things. You're going to have a lot of partnerships coming into place, which will give you tools to design and make visually appealing applications. But then the coding is weak and it won't do the work. Or you would have huge setups of things coming by, which will help you do great solutions. But like how TCS has told us, the client takes 2 minutes to look at the application, and the interface is bad, he throws it out of the window. So you need to balance all the three, and that is where we are saying for anybody to enter Unity, either you are someone who likes programming, doesn't like programming, or likes to actually even create visuals. You're all invited, because this is one particular tool. For every tool that we sell to a company, they need 2 people minimum. One is the designer and the other one is the programmer, to work together to create solutions. So that's why we say everybody can participate in being a Unity programmer or Unity designer. Now, what do we offer, right? If you look at it, Unity Pro is the beginning of the things. It is free for students. Students can go apply it on the website and collect it. It's free for educators. For personal usage, educators can just download it from the Unity website and start fiddling around with it. And for universities and colleges, we are offering them a big discount. When I say big discount, 80% of the thing is already waived off, right? And then we also give access to our corporate tools. So when I say corporate tools, we have Mars, which only focuses on creating your AR/VR studio. Unity Reflect, which only works with construction studios. Then you have Art Engine, which helps you make fabulous designs. And then you have Furious, which tells that you don't need a high-end laptop to run Unity. You can just buy a virtual Furious access, work, learn in Unity, everything's done, and then you can just push it across. Now, apart from that, we have a lot of other partners who make our solutions faster. Now, what is our basic pipeline? Whatever is your existing tool, Adam, Bentley, MATLAB, anything that has 3D point cloud data or even LiDAR.
Hello, Jainaresh sir, please make it full screen.
Pardon?
Make it full screen. Presentation mode.
All right, just give me a minute. All right.
Thank you. Thank you.
All right. So whenever we use your existing tools, we can collect data from that. So if you are, let's say, from the architecture school and you're used to SketchUp, we work with you. If you are from the film school and you're used to working with Radius Max, we already have integration with you. If you are from the engineering background and work with Rivet a lot, right, or an Inventor, we already have the tools to bring you in. Just import that particular data using one of our existing partnership programs, right? Bring it inside Unity Pro. The biggest reason why people use Unity is Unity supports 20 different platforms. Like when somebody asks me a question, how are these devices different? You have Sony, Microsoft, Nintendo, you have what is the other set of guys we have? We have people from Magic Leap, Google, Apple, everybody relying on Unity, right? And the biggest change is you build once in Unity, you can deploy to n number of people here. So you can push it to 20 different platforms, but your solution just needs to be built only once. And you can build your solution with the existing tools that you have. Let's say if you want to deploy for AR goggles, right, which iPhone is going to come up in future. Today you could work with your mobile phone, use AR Core or ARKit, design your application, understand how to deploy it later on. And even if you release it in the market today, and tomorrow you want to support it, all you have to do is build one more extra additional solution from the same Unity. So what each of them does, like I told you, Reflect, which is for engineering and construction services, Art Engine, film, real-time games, anybody who wants to actually do AI-assisted artistry. Okay, practically if you can take photographs of your college or school room, put it into Art Engine, it will actually give you a 3D output of it. So you don't have to worry about anything else. Mars, the context-aware AR development system, and Furious, which talks about how to embed your application into websites or use without a laptop on Unity. Now, what are the other things which are coming by? We created a fabulous Unity simulation system for LG, right? So LG today designs its experience cars not in real world. They define it with all autonomous sensors and connect it to Google Maps and let the car run virtually. So LG's car is now running somewhere around Los Angeles and New York, and it's all virtually done, but it is actually being done on real maps, which most of the cars actually navigate and trust by. So today, Unity simulation is a thing that we will be extending very soon, where students can train not only their cars, but also drones. If you are building your drones in RTOS platform, you could just build on it. In fact, we had a very fabulous example shown from Sri Lanka, where a few students hooked up 5 drones, trained them in Unity for automatic weeding and what was it called? Weeding and seeding experiment. So we were surprised to see students actually able to use this kind of a training program where the training speed was around 20x. So which means like in 20 days, it had 400 hours of learning, which is what it needs to be certified as a proper drone. So Unity Forma is again an interactive application creator. This is where you don't need a lot of programming. You can just use this, build your experience, and fast track the entire process of sales. The HMI solution, so it could be your own car, it could be your own dashboard, own tablet, own smart TV. Now you could create whatever you want with all of them inside this. So I think we are already late, and I'm going to just jump on to the demos. So these are a few of the people who use Unity. Hold on, let's just jump onto the demo so that we see a lot more stuff. But yeah, again, this will not have audio, or it will have audio. Just give me a minute. Great. We do have something similar to show you. All right, so stop sharing, get back here, listen now, Chrome tab, cross industry vertical, share. Right. So that was an example of how we are changing things. But ultimately, if you don't like the serious side of the world, anyway, for people who are the millennial kids and people who follow the millennial kids, Unity is a new name in this particular space only because our name has a bigger dominance in the gaming market. So if you are playing games or if you're used to playing games like PUBG, Call of Duty, Subway Surfer, Angry Birds, all those games are actually built with Unity. So that brings us to the end of the presentation. I will take a few more questions here. What is the minimum system requirement for the implementation? Okay, and also what is the cost of AR/VR goggles? So that you could start as simple as your existing laptop and your mobile phone with no additional cost, because Unity supports Euphoria integration. So practically you just need to start a project in Unity, go into libraries and enable Euphoria and you're good to go. Any existing laptop which is i5 and above is always welcomed by Unity to be run on. So there is a minimum and maximum or recommended systems depends on what you actually want to show, right? For example, if you are looking to do a full-fledged VR, then you might need something like 10, 20 missions. You would need something of, let's say the Reverb G2 headsets, 20 of them, so that you can start all building and collaborating in 3D and putting it across. And an RTX 2060 is the minimum recommended graphics card for VR. So as long as you are working with AR, there is nothing big in that. Right? Anything else? So we have covered the most basics of things, and thank you for everyone being here. I know I overshot the time a little.
Thank you,
So,
sir.
ladies and gentlemen, we have now come to the end of the third session and also the first day of Atal FTP. And we all have seen a couple of questions on the chat box. Many of you have already posted your queries in the chat box. On behalf of the organizing committee, we are extremely grateful to Mr. Jainaresh for the clarity which he provided on the difference in virtual, augmented, and mixed reality systems, along with showcasing very interesting and realizable applications of extended reality and presenting very interesting demo videos. So thank you so much for giving us your worthy time amidst your personal emergencies.
Thank you.
May I now request Professor Priyadashi Kanungo to speak a few words towards the conclusion of today's FTP. Sir, please.
Thank you, Soumya Madam. Thank you, Jainaresh sir. Thank you all the participants. And tomorrow, if you look at, we have already supplemented all these program schedule. And tomorrow we'll go for a hands-on build of this AR and VR. Or similarly, industry experts will be delivering all these sessions, next sessions. Hopefully, we'll enjoy the next sessions, last 4 days, the next 4 days of these sessions. Thank you again. Thank you all participants. Thank you, Janesh sir. Thank you, Soumya Madam and Sally Madam.
Thank you, sir. Thank you.